All right, here's 5-2, day 1. One of those learning targets, even though it's split up into 2 days, it's really just one topic. And honestly, it's not even really a new one either. In section 1, we did, the instruction said to simplify. But the only difference with verifying a trig identity, I'll scroll down to our first example here. Okay, you know what it equals, all right? But as far as the steps that you would go through to show that those two sides are the same, it's the same process. You're going to factor if you can. You're going to add fractions if possible, and then you're going to apply the identities to take typically the more complicated side, like the left, and to get it to equal the right. And that's what I'm going to start with here and say, all right, secant squared theta minus 1 over secant squared. Okay? Now, I need to show that this will equal sine squared. Okay? Now, the fact that we're dealing with squared terms, right? And by the way, the other possibilities of what I could do to factor, that's not going to work here. Add or subtract fractions. I've only got one fraction. I don't have two of them to add. I'm going to go to an identity, and because I'm dealing with squared terms, the first ones I looked to were Pythagorean. And secant squared could be replaced with 1 plus tangent squared. That would be all over secant squared, and that is a step that I need to cite right over here. Just PI for Pythagorean identity. Up top, I have plus 1 and minus 1. Those will cancel out, and the only thing I'm left with is tangent squared over secant squared. My next step here is going to involve an identity. I've got tangent, and I'm going to switch it to multiplication, but then go with a reciprocal, which I will cite that that's what I did. I used a reciprocal identity. I'm keeping in mind as I'm doing this where I should be headed is sine. We have a quotient identity that states that tangent can be rewritten as sine over cosine. I still am multiplying by cosine squared there. That was a quotient identity. The cosines cancel, and sure enough, that whole thing simplifies to sine squared. Okay? If you're comparing this to the last set of notes that we did in section 1, nothing different. Especially when you were doing those simplifying problems, if you went to the back of the book and then looked up what you're supposed to get, this is really no different, right? The right side, the sine squared, is like, hey, that's what you would find in the back of the book. That's what you should get when it's all said and done. All right, take a look at this one. Certainly looking like we're going to start on the left side, right? A lot more to potentially be simplified. Now this is that case where I'm not thinking identities, because honestly, of all the identities, nothing really seems to fit the left side. I've got two fractions that I would like to add together. That variable, by the way, is alpha. So I'm going to start with that left side. And here's a little trick that you can use to get a common denominator. Is you can take the two denominators that you have, like 1 minus sine alpha and 1 plus sine alpha. And you can just multiply them together. Do the same thing over here. 1 minus sine alpha and 1 plus sine alpha. Losing space there. Okay, so now what's going on the top? Go back to our first term. That was originally 1 minus sine alpha. I multiplied it by 1 plus. So I got to multiply the top by that as well. And 1 times 1 plus sine alpha is just 1 plus sine alpha. And the opposite would take place over here. The bottom of that fraction was multiplied by 1 minus sine alpha. Got to do the same to the top. Okay? When you're adding fractions, you just keep the common denominator that you found. This will be one term now. That's 1 minus sine alpha times 1 plus sine alpha. On the top, I have a positive sine alpha and a minus. That cancels. And then 1 plus 1 is 2. And I get a 2 on the top. Now you think about this, that's a good sign because notice over here, okay, we should get a 2 in our final answer, and we have it. Haven't cited an identity yet. We haven't used one. Okay, I'm now going to FOIL the bottom. When I do that, I get 1 minus sine alpha. This would be a common point where you may get stuck, okay, after we get to here, because we recognize right away we've got 2 fractions to add, and here we're like, okay, we did it. Now what? I don't think we're going to do it again, obviously. Can't factor. Leads us to identities. Okay, anytime you see that squared term, I immediately think of Pythagorean identity. And sure enough, you would find, I need to cite it here, but 1 minus sine squared is cosine squared. Last step here to finish this one off. I could do the reciprocal of cosine, which is secant, and we got exactly where we were supposed to go. That simplifies to 2 secant squared. We head down here. Okay. I'm going to start on the left side, except, I can't factor. Kind of looks like it already has been. I don't have any fractions to add. It definitely doesn't feel like the last case. Which leads us to identities. Okay, if you can't factor and you can't add or subtract a couple of fractions, you got to think we should be doing a substitution with one of the identities right off the bat. Both of these are squared and they both feel very Pythagorean. Okay, tangent squared plus 1, if you were to check what you have, you would see that is secant squared. Cosine squared minus 1 is negative sine squared. Now, I ran out of room here, but what I should say is right next to it, pi times 2. Okay, and that's fine if you do that. I mean, it's clear enough there that the Pythagorean identity is what we're using, and we did 2 of them. Okay, which looks like good progress here. We've got squared terms, and all of this should be headed towards negative tangent squared. Okay. Negative sine squared is not, I could go right back to cosine squared minus 1, but that seems silly. Secant, I could go to a reciprocal. Still multiplying by negative sine squared. That was a reciprocal identity. Now I could multiply these together, and I would get negative sine squared over cosine squared. Sine over cosine, wait a minute, that's tangent. I still have that negative, it's squared. That was a quotient identity, and sure enough, we end up at negative tangent squared.